There are basically an infinite number of trigonometric identities. Only a few of those are famous or important enough to have their own names or their own sections in a textbook. The tangent of x times the sine of x equals 1 minus the cosine squared of x divided by the cosine of x. This is a trigonometric identity. It doesn't have a fancy name. It doesn't get a section in a textbook. It is nevertheless true. For no matter what x is, this equality holds. And the process of verifying a trigonometric identity it's really a mathematical proof. It's looking at an equality like this and saying, why does this always hold, though? How can you be so confident and say that this is an identity? Well, let's take a look at what we have here. Let's take a look at the left-hand side of this. And let's remind ourselves that the tangent is the sine divided by the cosine. So we've got the sine divided by the cosine times the sine, which is the sine squared divided by the cosine. Now, that sine squared is hopefully ringing some bells, because we've seen it before in the Pythagorean identity. The sine squared plus the cosine squared equals 1. If we take the cosine squared and subtract it, then the sine squared is 1 minus the cosine squared. The sine squared is 1 minus the cosine squared. And there we go. We started with this product on the left, and first we rewrote the tangent. Then we did some simplification to go from the sine of x times the sine of x to the sine squared of x. And finally, we used an identity, the Pythagorean identity, to say that the sine squared of x is 1 minus the cosine x. This process, where you demonstrate that a trigonometric identity is true, is called verifying the trigonometric identity. So we have verified this identity up here. And there's no one-size-fits-all trick to verifying identities. You just have to kind of look at it and think about the identities you already know, and think about what you can do, and do some trial, maybe make some errors, trial and error, until eventually you hit on the right argument. You really need to just develop experience if you're going to do this. Like, looking at this example, saying that the sine times the sine is the sine squared, I mean, that's just algebra. But looking at the sine squared and saying, wait a minute, I know an equality. I know an identity involving the sine squared. I know that the sine squared shows up in the Pythagorean identity. That's just something you gain with experience. Let's see. I don't want to do all of the examples in the textbook. It would become quite tedious. I think you'd be sick of my voice before we got to the end of the video, but let's do example 3. Example 3 says that 1 plus the sine of x times 1 plus the sine of negative x equals the cosine squared of x. So the general rule of thumb when you're trying to verify an identity, and I'm not going to write it on the whiteboard, but that's our goal here, to verify the identity. The general rule of thumb is to start on the side that looks more complicated. So in this case, the left-hand side. We think, what can we do here? And there are a few things we could do here. We've got a product. We could FOIL that out. We've also got the sine of negative x. And we have an identity involving the sine of negative x. We know that it's negative the sine of x. So what we want to do, well, we've got 2 things we could try. It's not clear that one of them's better than the other. Let's try foiling this out and see what we get. 1 plus the sine of negative x plus the sine of x plus, and then we've got the sine of x times the sine of negative x. And at this point, okay, we've still got the sine of negative x. In fact, now the sine of negative x is showing up twice. And I'm not sure what else there is to do. So let's see if using this identity helps. The sign of negative x is negative the sign of x. So this is 1 minus the sign of x plus the sign of x. You see this sign of negative x, because this negative sign there, that's why we have that negative sign there, plus the sign of x times the negative sign of x. And now where are we at? Well, we've got a negative sign of x and a positive sign of x. Those go away. Then we've got this addition and that subtraction. So those are going to turn into a minus. The sign of x times the sign of x. So I'm going to pause for a moment. I'm going to ask you to give some thought to what we should do now. What we want is the cosine squared. What we have is the sine squared. Do you know an identity that relates those things together? We sure do. The Pythagorean identity relates the sine squared to the cosine squared. We have 1 minus the sine squared. If we take this and we subtract the sine squared from both sides, the Pythagorean identity becomes the cosine squared is 1 minus the sine squared. So 1 minus the sine squared equals the cosine squared. And this equaled this, equaled this, equaled this, equaled the cosine squared, which is exactly what we wanted it to equal. And with those two examples, I'm going to end this video here.